Welcome, everybody. This is another session of our WNS Leaders in Neurosurgery interview series with a fireside chat with Dr. Robert Gross, a longtime colleague and friend of mine. Really pleased to be able to chat with them today and discuss some of his milestones and achievements in his career. I want to thank WNS for this series, and we're going to jump right into it. Dr. Gross has, recently been appointed as the new chair in the Department of Neurosurgery at Rutgers University, incorporating two medical campuses at Robert Wood Johnson and New Jersey Medical School. Dr. Gross was at Emory for over 20 years, where he really led the way in neuromodulation and epilepsy surgery, really developing new approaches and new research that's really kind of paved the pathway moving forward for neuromodulation. He's a well-funded NIH neurosurgeon scientist, and he's mentored a number of fellows, faculty, residents, and has really left his mark in terms of training the next generation of neurosurgeons. So welcome, Dr. Gross. Thank you for joining us today.
My pleasure to be here. Thanks for inviting me.
Well, excellent. So, one of the things we like to discuss in this series is kind of, what defined your path and helped you get where you are at this point in your career. You've done so much in neurosurgery, contributing to generations of training of neurosurgeons, but your research has also kind of elevated the field. Can you kind of just tell us what your goals were early in your career that led to where you are now?
Thanks again, Costas, and it's so nice to see you. I started just sort of following my nose. I went to Brown University. I was majoring for the first semester in engineering, floundering, didn't really find my footing there, and switched to computer science. And then in my sophomore year, I took a psychology course, and frankly fell in love with mental illness, and schizophrenia, and the role of dopamine and neurotransmitters. I think when I finished college, I was intending to first do a PhD and then do ultimately an MD PhD when I discovered that, and go into psychiatric research. I wanted to be a biological psychiatrist. So that's where my first love was. I ended up going to Albert Einstein. And as I got more exposure to deeper and deeper and lower and lower levels of the nervous system and molecular biology and genes, I kind of followed my nose. And frankly, I was a heartbeat away from dropping out of the MD portion of the program, thinking at that point I was doing research on C. elegans and neurodevelopment and the molecular genetics of neurotransmitter systems. And I thought I had been interested in medical school just long enough to get into medical school. I went to see my MD PhD director, Betty Diamond. This is back in 1988. Betty Diamond, by the way, is still directing MD PhD programs, 30 some odd years later, 40 years later, at Northwell. I saw her recently. And she managed to convince me to just finish the program out. At that time, you could just do 13 months and leave. Nowadays, it would be 22 months. Probably wouldn't have taken that deal today. But back then, I figured, all right, I'll just do the 13 months. And I figured, all right, I'll do the hardest thing first, the second hardest thing second, the third hardest thing third, and just sort of take my medicine. But the hardest thing I thought was going to be surgery. So I guess I was going to take my surgery. And I almost was pushed kicking and screaming back onto the wards against my will. But within 48 hours of being on the trauma surgery service at Jacobi Hospital in the Bronx, fell in love with surgery. And I didn't anticipate this at all. and finished out the month and thought about what am I going to do now? I love surgery, and I'm a neuroscientist. Well, neuroscience plus surgery, neurosurgery. Kind of a fly-by-night idea, actually. I went to see Alan Hirschfeld, who was the lone surgeon at that time at Jacobi Hospital, an NYU grad. And I asked him, so what relationship is there between the neurosurgery department and the neuroscience department? And he basically answered, can you repeat the question? So I was a little bit dismayed, but then decided, well, if there is not really any relationship between these two streams, then I'll be the bridge that will form this relationship, and I'll become a molecular and cellular neurosurgeon. And so with that, I used my one elective month to rotate on the Montefiore Albert Einstein service, and really just kind of got lucky. Probably no one would take a chance on someone like me at that point, but my chair, Paul Kornblith, his area of expertise was on protein kinase C in glioblastoma, and my PhD was on protein kinases. And I think he just took a chance on me, and almost the rest is history. My goal actually at that point was to do cellular neurosurgery. This is back in 1990. This is before DBS, really, before pallidotomy. I arranged a postdoc with Anders Björklund in Sweden. But right in the middle of my residency, 1992, 1993, came the first paper on the reinvention of pallidotomy for Parkinson's disease. And I think I kind of just luckily defined the Wayne Gretzky saying, you have to skate to where the puck is going to be, not where it is. And I was just right in the right place to catch that puck, all ready to go. Ended up doing a fellowship in DBS and took off from there. So I didn't really have a great plan except to sort of follow my nose into what was interesting and what I felt passionate about, and it's worked out.
You've really defined your role as a neurosurgeon scientist, and that's something I've also taken heart to and really believe in. Can you discuss with us the importance of incorporating research as a neurosurgeon? I mean, you've led an MD, PhD program, training, medical scientists in a training program, residents. Why should we be doing research as trainees? Is that really important for their career as they go out into practice?
It's a great question. I'll answer that by sort of broadening it out a little bit and connecting as to why I fell in love with surgery as a scientist. You would think that would be completely diagonally opposite to it. But I think what really caught me, and it took me years to figure out, was the similarity between being a scientist and being a surgeon. When you're a scientist, you identify an area that that has sparse knowledge. If you identify an area that has rich knowledge, well, there's not much of a role you can play. So we find areas that have sparse knowledge. We learn everything we can about the field, and we identify the knowledge gaps. And then you design an experiment to fill the knowledge gap with a hypothesis. Almost invariably, it turns out wrong. And you reiterate that whole process. You take the knowledge that comes out of your experiment, you feed it back into the top, come up with a new hypothesis, and do this iterative cycle, all to fill this knowledge gap. In surgery, we're really in the same position. We confront a patient, and specifically in surgery, maybe more so than in medicine, we're confronted with a dearth of knowledge. Glioblastoma, how much do we really know? There's so much we don't know. Same is true in functional neurosurgery. And you're faced with a patient with epilepsy, and you don't know exactly where it's coming from. You learn as much as you can, both about the field and about the patient. And then you say, well, I think it might be coming from your frontal lobe. And so you design an experiment to test that. You put stereo EEG electrodes in, and we actually call them hypotheses. I'm going to test this hypothesis and that hypothesis. And you do the experiment and you take the results and you use it to decide on the treatment for the patient. And I would even argue that the treatments are always experiments because we don't know the outcome of them. But the iterative cycle is so much faster than research. So that's one of the things that caught me about surgery that I realized years later. And we are always challenging ourselves to figure out what to do for these patients. You, most especially as a glioblastoma surgeon, you're confronted with people who are dying and you can't do anything about it. But you learn as much as you can and you try to figure out what to do. And that, I feel as a physician scientist and as a neurosurgeon neuroscientist, is really what drives me. Knowing that sometimes I can help people, but I have to be pretty clever about doing it and doing that whole process. And a lot of times I can't. So we at the front line have this view of the treatment gaps that nobody else has. Your expertise, my expertise, bring us to that place that a scientist with whom we work can't possibly see. I call it climbing up the mountain and being able to get a much better view of the potholes that you can't see from the ground surface. And we uniquely know how to go about filling those gaps because we have the scientific training and acumen to know what can be done, how we can advance to the next step. And I think that is the most critical part of being a surgeon scientist, is taking advantage of that view that we have spent years to climb that mountain, to get that view, to figure out what to do and drive the field forward. And it's completely driven by our empathy for our patients. We wouldn't be doing this if we didn't have it. And our sympathy for them when we're sitting in the office and can't offer anything. It's not just empathizing with them, but it's feeling bad. And then going back to the lab and designing scientific experiments to fill the knowledge gaps so that we can ultimately fill the treatment gaps. And I've done that for every year of my scientific practice, including my most recent grant, which was on trying to figure out why anterior nucleus of the thalamus, DBS, how it works, so we could figure out how to make it better, because we do it and we don't even know how it works. How can we fix this car if we don't know how it operates?
Excellent. I agree 100%. We are in a position where we can determine unmet need in a way others cannot. And I like the analogy of climbing up the mountain and seeing over it. You've been in a field in functional neurosurgery for quite some time, really helping develop this field, also including epilepsy surgery. I mean, your days with Dr. Roy Bakay and Emory, right? You were with him at one point. And tell us a little bit about how the field of functional neurosurgery has evolved through your own eyes and where we're heading at this point. I know it's a broad question, but I know you have your own set of ideas about this.
Yeah. Roy Bakay, the late Roy Bakay, and unfortunately we lost the great Roy Bakay in 2013 due to stomach cancer. He was at Emory, and I met him back in 1994, and I actually considered doing my fellowship down at Emory, but I never actually worked with Roy. I chose to go to Toronto and work with Andres Lozano and Ronald Tasker, but I couldn't avoid it. Eventually circled on back here when Roy decided to move to Chicago, to his ancestral homeland, and finish out his career there. My perspective coming into neurosurgery in the early 1990s was coming into a field where there was no such thing as functional neurosurgery, as far as people like us just starting out could tell. This is obviously a different perspective than residents coming in now have. And as I said, the field it wasn't born in front of me, it was reborn in front of me. And we had pallidotomies all of a sudden being done. And that's what Roy led the way in doing down at Emory. as well as first Ronald Tasker and then Andres Lozano and other people across the world as it was reborn with Leighton's paper published in 1992. What a trajectory! I went up to Toronto in 1996 and all of a sudden learned about deep brain stimulation, which was essentially born or reborn in 1987 with Benabid's paper on tremor, and then in the early 1990s with STN-DBS and Malin DeLong's role in discovering the role of the STN in the MPTP monkey. So this whole field generated in front of me. And then I learned about doing surgery for depression and for OCD. And of course, we stand on the shoulders of giants because we look back, and I had the honor of giving the lecture at the SNS a few years ago, right at the tail end of the pandemic, on the history of neurosurgery. And the history of neurosurgery is the history of functional neurosurgery, which was done for Parkinson's disease and psychiatric disorders from the very outset. And then we had the opportunity to rediscover that as deep brain stimulation came along and provided a way to revisit psychiatric surgery in a way that was much more ethically palatable. But then, strangely enough, rediscovering ablation because laser came along and led us back into this, and then led us back into radiofrequency ablation. So what I see is a spiral staircase, and I think that's how science and medicine evolves, that you go up and then it comes back out. And, it sort of goes away and then it comes back, but at a higher level, and then it goes away. And it's this iterative cycle. It's much like the invention of the wheel, which was not invented singularly in one place and then all of a sudden took off. Oh, what a great idea. It had been invented time and time again, but it didn't have its most useful application until it was in the Levant region, and agriculture was all of a sudden born at the same time. They found wheels in Mesoamerica that were not even used for anything but toys. So we go up this spiral staircase. And as we are coming back into cell transplantation for Parkinson's disease, it's just a great example of that. Again, I went into the field wanting to do cell transplantation, but by 2001, it was gone because of the trials that didn't work. And now it's 2024, and we're back into cell transplantation for Parkinson's disease, but now with embryonic stem cells. So these things go and come and go and come. It's really important to know the history so that you can know that you're not reinventing the wheel, and another great, similar analogy, and stand on the shoulders of the people that came before. And with neuromodulation, it exemplifies this. DBS, and now we're into gene therapy. So doing gene-based neuromodulation that comes on the heels of everything we learned from DBS along the way. So it's been just a tremendous joyride to participate in it and watch it unfold. At the one time, exciting based on all the developments. And on the other hand, it's been so slow. So, decades, but it's just really exciting to see it from my perspective.
Oh, that's great. So you've assumed this new role at Rutgers where you're bringing together basically two campuses and trying to share your vision, which you've shared with us today. Thank you very much. What are some of the challenges and some of the things that you are hoping to achieve as you move forward, with this new position that you have?
Well, I had the great joy and honor to be at Emory, and you were at Emory for a number of years as well. I was there for 22 years. I inherited the program from Roy Bakay and had the great pleasure of growing it to ultimately 4 functional neurosurgeons at one point. And we were doing great things. We contributed to advancement in DBS. We contributed to advancement in LIT, in radio frequency, gene therapy, cell therapy. I think at one point when I've always had a very realistic base, and we do these things in the ivory tower, but I recognize that what we were doing were not things that could be necessarily applied widely. And a little bit of perhaps unconscious realization that it's just kind of a shame that not everybody can have access to these types of things we were doing. And I was interested in coming into maybe a little bit more of the real world, as you know from working at Emory, that we pretty much have the lock on medical care. I mean, there's other systems that are definitely developing and providing some competition, but there's no other epilepsy center, no other movement disorder center for miles around. And this opportunity came in New Jersey. I hail from New York to begin with, so my journey took me from New York north to Toronto, through New Haven, out west to Utah, my first faculty position, and then down south and back east, southeast to Atlanta. And suddenly, when this opportunity arose, I saw it as an opportunity to come back into the place that I was born and initially trained. I spent 14 years in the Bronx, and say, can I bring some of these skills and advancements into a very, very challenging, medically, economically challenging environment and make some progress? In New Jersey in particular, of course, there's fantastic medicine all throughout the East Coast, but there's the great centers in Manhattan, there's the great centers in Philadelphia. And it's been a great program treating a lot of patients that in Newark that don't have access to great medical care and providing that service. And even Robert Wood Johnson has a long history, even in functional neurosurgery. Bob Lehman, going back into the 1990s, one of the first people to do Richard Lehman, rather, to do pallidotomy, but not delivering at the level of care that you and I became accustomed to at Emory, at Mount Sinai in Pittsburgh. It seemed to me a shame that the 10 million people in New Jersey could not get care of the level that were being offered in those centers in their home state. And they certainly are as deserving as anybody else, including the disadvantaged patients as well as the advantaged patients that were also not necessarily getting lit laser ablation. I did over 60 ANT DBSs at Emory, and there wasn't a single one done in the state of New Jersey for epilepsy. So it seemed a shame to me, and it seemed a shame that this center, two medical schools, and a great State University of New Jersey at Rutgers, was not performing at the level of some other great state universities across the country and great medical systems. And they were in need. I offered up my services. I thought it would be a great new challenge to both bring the highest quality medical care for glioblastoma, for epilepsy, for Parkinson's disease into the community, help to elevate the practices of even all the private practitioners in our system who may sometimes not have access to the types of things that we can do, and to avail ourselves of the over 260 neuroscientists that are in the Rutgers system and bring together the stream that I've led in innovation, starting a center at Emory and starting that same type of neurotechnology innovation center in Rutgers in an ecosystem that is replete with big pharma and industrial collaborators. So it's just seemed like the right opportunity for me to do the best good that I can, getting towards the tail end of my career, bringing it all together and taking on a great new challenge.
Well, Rutgers is so lucky to have you. Why don't we wrap it up? I think, one of the things that would be nice to share with the viewership is, you've accomplished so much, but you also have a very wonderful family that you've been part of and, grow, and they've helped you grow as an individual. Can you tell us a little bit about how you balance all this, with your family and kind of, at the end of the day, how do you keep yourself, moving forward, and how do you take care of yourself?
Oh, those are great questions because, as you know, you're in Pittsburgh, and Joe Maroon made a great point of that over
Yeah.
his career about coming into imbalance and then finding his way back into balance. Um, and we are very prone to this. You know, we're MD, PhD, neurosurgeons, director of this, chair of that. We're very prone to going out of balance and really just leaning on the intellectual and work side of life. I was fortunate that I think that I didn't have children until I was a little bit older. I was 43 when I had my daughter. And at a point in my career when I was maybe rounding the curve and feeling more accomplished and more confident, and able to sort of get off the wheel a little bit and pay attention to my family. I do remember, I wonder if this is a false memory or not, but in my memory, I was sneaking down the back stairs from the clinic at 7:30 at night, thinking, I hope no one sees me going home. When I had my first child. But I was able to kind of use the empathy I have for my patients to have that same empathy for my family. And when my daughter needed me, or my son needed me, and my wife needed me, I responded and said, look, of course, patients, we say they come first, but you can't take care of patients unless you are able to, and healthy. And part of that health is your family. And so I was able to make those decisions on a point by point basis. I remember at least 2 times canceling going to a meeting. One was to India the day before. I was going down I-85 one day, and I turned the car around and went back to my house because my family happened to need me at that moment, and passed off the obligations I had at the CNS. And you just have to prioritize them because, we can't go this alone. We need their support, and I've had the fantastic support of my wife Angela that and who's just such a great moral and spiritual support for our family and for me, that I've had to rely on more and more, really, as time goes by. And my kids, I was present for them when I needed to be. I read to them every night. And that sort of investment comes back. And that is those are our legacy. Our legacy are our children,
Right.
our loved ones, are our mentees. That's really our only legacy, in my view. And I think we really need to focus on that. And I find that in this job now, which is very challenging, I have 2 medical schools that whose departments I'm running that are separate, and a health system. And it's really easy to get out of balance. So I prioritize squeezing in physical health. I work out regularly. I found an hour this morning and went to the gym. And I prioritize sleep, and I no longer venerate, having that reputation of not sleeping. It's not healthy. It's not how you run a marathon, not a race. And so I prioritize all those things, and I encourage all my residents and trainees. And as you probably know, I have a big investment in the right diet. And I think that's a very important message to pass to our trainees as well, because as I used to tell the MD PhD students when I was director of the program at Emory, and they would say, what does a success look like to you for them? And I said, a success is that when you're 100 years old, because you probably will be 100 years old, that you are still contributing to the betterment of mankind through medical science. So we make these investments in ourselves and others, and we want to be able to, really maximally avail ourselves of everybody's talent and experience, till our dying hour. And having balance in your family so that you can do that is the only way to go about that.
Well, that was wonderful. I really want to thank you for taking the time to be part of this. I think we all really learned a lot, and I certainly have enjoyed, being your colleague and friend through the years. I've learned through so much from you. So I think, once again, thank you very much. And I want to thank the AANS once again for letting us, have this fireside chat with Dr. Gross. And Have a great afternoon, everybody.
Thanks, everybody. Best wishes. Thanks, Costas.
Thank you.